Hello Math 152 students. In this video we're going to address some topics in 9.1. 9.1 focuses on population proportions, something we've been discussing a lot, particularly in section 8.2. There's 3 objectives in the section, and this video is really going to address the first 2. Your book has some really good examples of the third. 1 and 2 are where we're going to do some by hand, and in particular 2 is where we're going to do a lot of StatCrunch work. So the first thing we'll focus on is obtaining a point estimate, making sure we understand that vocabulary, and objective 2, construct and interpret a confidence interval for the population proportion. Topic 3 is going to deal with the sample sizes and estimating what sample size you would need if you were going to gather data. So let's take a look at a definition. Your book says that a point estimate is the value of a statistic that estimates the value of a parameter. This is a little bit vague because the statistic could really be anything, any number that we're talking about. Most of the time, the statistics we're interested in are proportions, means, and then in other courses, maybe the standard deviation or the variance. For us, we're going to deal with population proportion and then population mean. So for the example, the point estimate for a population proportion is p hat equals x over n, where x is the number of individuals with the specified characteristic and n is the sample size. We have seen this p hat in 8.2, where we just calculated proportion. And in fact, all of this definition makes it seem a little bit harder than it is. Let's look at a specific example. Our context here, in July of 2008, a university poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. So we want to obtain a point estimate for the proportion of registered voters nationwide who are in favor of the death penalty. So what it means is obtain a point estimate. From this information, we could get a proportion. The proportion would be a single number. A point estimate refers to a single number, whereas a confidence interval is going to be a range. And we're using the sample data. So it's an estimate for our nationwide information. In other words, all we would have to do is do a quick division and get 0.63, or 63% of my sample told me they were in favor. So I could estimate that 63% of my voters nationwide might feel similarly. Now, 63% of my sample doesn't mean that exactly 63% of my population are going to feel the same way. This is just an estimate. If I were to even obtain a sample of 1,783 other voters, I would not be getting this 1,123 yeses again. I would probably get something different. In other words, my p hat is going to change sample to sample. I might get a proportion of 0.65, 0.7, 0.58. Different proportions, different sample proportions for different samples. Our estimate is the best that we can do, only given 2 numbers that we're calculating a proportion with. So can we do better? The answer is yes, and that's what we want to do with a confidence interval. We want to take our point estimate and add and subtract a margin of error. Here, the margin of error you can think about as gives us some accuracy to our point estimate, but it gives us a range. I feel much more confident looking at a range instead of a single number. It tells me a lot more information. So let's take a look at what we know. This slide is just to remind us of some background information that we saw in 8.2. We learned a whole lot about the sampling distribution of p hat. We learned how to find the mean and the standard deviation, and we learned the conditions under which the sampling distribution of p hat is normal. So all of this background information that we did in 8.2 is going to come up again. Some of the formulas we would use if we're doing things by hand, but the conditions we're going to have to check again and again. So it's going to feel kind of similar to the setup in chapter 8. Now, for this slide, I'm showing you some of the by hand formulas that your book discusses for how to find the lower bound and upper bound on a confidence interval, then kind of skipping ahead, a margin of error formula. What I want to tell you is that these formulas utilize the formulas in 8.2, but StatCrunch can do this for us. So what I'm just going to observe is the components. For our margin of error, notice that this piece you see in what you're subtracting and adding. This right here is the margin of error, and that right there. So the margin of error has to do with your standard deviation, and it also has to do with your alpha, which is related to your level of confidence. So let's go back and discuss this level of confidence for just a minute. I don't want to get too technical about this part yet because I want to get us into some examples, but there's 3 levels of confidence that we're going to look at. Here, this 1 minus alpha times 100%. Normally in a problem, they're not going to give you this. They're going to say, calculate a 90% confidence interval, or a 95%, or a 99%. Those are the most 3 common. A 90% level of confidence gives an alpha of 0.1, or 10%. A 95% level of confidence has an alpha of 0.05, or 5%, and a 99% has a alpha of 0.01, or 1%. So the level of confidence relates to this alpha, and the z-sub alpha was something we discussed in chapter 7 with the area and the tail of those normal distributions. So you may remember seeing this notation a little in chapter 7. Again, for the most part, what we're going to do is ask StatCrunch to give this to us, but it's worthwhile to look at a couple examples by hand just to see what's involved for the by hand calculation. So I don't want to spend too much time on this. I want to show you what you're actually going to do in practice and then discuss some of the theory a little bit more. Here, exact same example, and this is the part of how you're going to see the phrasing in the questions. They're going to ask you to obtain a 90% confidence interval, or maybe 95% and 99, for the proportion of registered voters who are in favor of the death penalty. Notice they say for the proportion of registered voters nationwide, I think I didn't say that part, but it's not a confidence interval for your sample. It's a confidence interval for your population, and it's using your sample data. So let's take a look at what we need to do. The first thing you have to do is check your conditions. Before you can use StatCrunch and use any of those by hand formulas or the StatCrunch process, you have to make sure your p-hat has a normal distribution. So this goes back to the n times p times 1 minus p having to be bigger than 10. And this part is our condition that our sample can't be more than 5% of our population. Here the little n is our sample size and the capital N is your population size. It's that 5% rule. As long as this checks, we're going to go straight to StatCrunch. So the last thing I want to point out before we check these conditions is the p-hat. In your chapter 8, it was just a p because we had the population proportion given to us, whereas here we only know the sample proportion. We're trying to estimate the population proportion, so we don't know the p. We just know the p-hat. So what does this look like? Here, for this condition, our n is the 1,783. Our p-hat we calculated was 0.63, I believe. And then we want to calculate our 1 minus p. So you could put in parentheses in your calculator or put in 0.37. So when I put this into my calculator, I'm getting approximately 415. So the point that we want to see here is that this is much, much bigger than 10. Okay, so that checks our condition. And the second condition is our 5%. Here, our 1,783 is pretty small compared to our total number of nationwide voters. We don't actually have a number for that population, but we could say something like this is less than 5% of all registered voters. So you want to actually write out these checks as part of your process before you ever go to StatCrunch. So now let's go to StatCrunch, calculate this, and focus on interpreting. So let's just go into a blank StatCrunch page, and you want to choose your stat option. We're looking at the proportion, so choose your proportion stats, and we're dealing with one sample. We will deal with some two sample cases in chapter 11 for hypothesis testing, and if we had two samples and we wanted to do two confidence intervals, we could look at our two sample. Now you do have the option with data or with summary. We actually have the summary, and we don't have a line by line yes or no for each person surveyed. So most of the time you're going to choose the with summary option. And notice it asks you for the two key pieces, the number of successes and the number in our sample. You want to choose the confidence interval and make sure you adjust your level. We were asked to give a 90% confidence interval. If they ask you for 95%, 99, just modify this. And there's two methods. We're going to use the standard method. We're not really going to discuss too much of the difference between these two. I don't think you'll run into any place your textbook gives them, but they're not in your homework, where they ask you to use an alternative method. So you could compute, and notice it reminds us of our sample proportion, and then it gives us a lower limit and an upper limit. This lower limit and upper limit gives us the range for our confidence interval. The other thing on here is the standard error. The standard error is the standard deviation for your p-hat that we actually calculated by hand in 8.2. But what we really want are these two pieces. Most of the time, MyMathLab will tell you where to round. We could say approximately 61%, 65%. If they just want us to give to the two decimal places here, 0.61, 0.65. And let's take a look at how we would interpret this. We are going to say kind of a standard sentence with confidence intervals. We always repeat the confidence level and say we are 90% confident, or 95, 99, whatever our confidence level, that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 0.61 and 0.65. So you're giving your lower bound and your upper bound for your confidence interval, and we're saying we're confident that our actual proportion is between these two. Now, does it mean there's a 90% chance? Not really. That's not what a confidence interval is saying. I'll illustrate a little bit more of that in a minute. But it's giving us a 90% confidence that we have, or 90% confidence in this particular range. So, and just as a side note, the confidence is actually the confidence that you have in your procedure to work. I'll get into that in just a second. But what I want you to take away from this is kind of the pattern of how we're saying it. Here, we'll always start off repeating your confidence level and then your lower bound and upper bound. The other thing, make sure you're referring to the proportion of registered voters. Think about this as the proportion of registered voters overall in our population, and doesn't tell us anything about our sample. For our actual sample, we found a 63% proportion. And then we use that to find our confidence interval. So the next part, I want to just go back to StatCrunch for a second and show you that if we go in and edit these, let's say I take another sample and I still get 1,783 participants, but this time I get 1,200 yeses. If we checked our conditions, they check. I'm going to skip that for a second and then show you what happened to our sample proportion. Notice with a lot higher number of yeses, I'm getting a higher proportion, and that confidence interval is going to shift up and be centered around my sample proportion. So if these were my numbers, I would be 90% confident that our population proportion is between these two values. So our next video is going to pick up with this idea of what a confidence interval means in terms of another way to think about these two levels.